Good day everyone, this is Professor Maria Luisa Bainyo Salingay, welcoming you to my discussion on reduction-oxidation reaction or redox. Before going to redox, let's first review the rules on determination of oxidation number. Number 1, atoms in its elemental form has oxidation number equal to 0. So water molecule, hydrogen gas, have oxidation number equal to 0. Number 2, monoatomic ion has oxidation number equal to its charge. Calcium ion has oxidation number equal to positive 2, and sulfide ion has oxidation number equal to negative 2. Number 3, non-metals have negative oxidation number, while metals have positive oxidation number. There are some exceptions. Oxidation number of oxygen is negative 2 in both ionic and molecular compounds except in peroxide where it is negative 1. Oxidation number of hydrogen is positive 1 when bonded to non-metals and negative 1 when bonded to metals. Fluorine has oxidation number negative 1 in all compounds, while other halogen have oxidation number of negative 1 in most binary compounds. Halogen, when combined with oxygen, like oxyanions, have positive oxidation state. Number 4, the sum of the oxidation number of all atoms in a neutral compound is equal to 0, like calcium sulfate, ammonium chloride. The whole compound have oxidation number equal to 0. Number 5, the sum of the oxidation number in a polyatomic ion equals to the charge of the ion, like sulfate ion have oxidation number equal to negative 2. Ammonium ion has oxidation number equal to positive 1. Now let us go to the basics. Reactions involve transfer of one reactant to another. Reduction reaction occurs when electron or electrons are gained and there is a decrease of oxidation number. Oxidation reaction occurs when electron or electrons are lost and there is an increase of oxidation number. Redox can be further understood with half reactions. In reduction reaction, for example, in Fe plus 3 plus 1 electron gain becomes Fe plus 2. Manganese plus 7 plus 5 electrons gain becomes Mn plus 2. And chromium plus 6 plus 3 electrons gain becomes C3 plus 3. Oxidation reaction. When Sn plus 2 loses 2 electrons, it becomes Sn plus 4. When 2-chloride ion loses 2 electrons, it becomes chlorine gas. When hydrogen gas loses 2 electrons, it becomes 2 atoms of H positive 1. Procedure in balancing redox half reaction method. Number 1, you divide equation into oxidation and reduction. Number 2, balance each half reaction. You balance hydrogen and oxygen loss. When you need to balance oxygen atoms, you add water. When you need to balance H atoms, you add H positive. When you need to balance charges, you add electrons. Number 3, multiply half reaction by integers as needed. Number 4, simplify by canceling species that appear in both sides. Number 5, check if atoms and charges are balanced. Let's do a simple redox reaction using half reaction method. Manganate ion plus oxalate ion to produce Mn plus 2 plus carbon dioxide. in the half reaction method, first we do reduction reaction. MnO4 -1 will produce Mn plus 2. If you notice, there are 4 oxygen here. To balance, you add water. When you add coefficient 4 before water, so 4 molecules of water, you also add 8 H positive. To balance H positive, you add H positive 1 at the left. Now, in adding H positive at the left, you balance the equation at the left and the right, the number of oxygen and hydrogen also. But the charges are not balanced. To balance the charges, you need to add 5 electrons at the left. Now, in adding 5 electrons, so the charges will be -5 plus 8 is +3 plus -1 is +2. So +2 at the left and +2 at the right is already balanced charges. Now we go to oxidation reaction. Oxalate ion to produce CO2. If you notice, there are 2 carbon here and 1. So you add coefficient 2 before CO2. Now the number of carbon and oxygen is already balanced, but not the charges. This is -2. So to balance the charges, you add 2 electrons at the right. Now it is already balanced. Now you have a balanced reduction reaction and oxidation reaction. Now you have to add. To cancel electron, you have to multiply this whole equation by 5 and this one by 2. So in multiplying this by 2, you have 10 electrons plus 16 H positive plus 2 manganate ion to produce 2 Mn plus 2 plus 8 molecules of water. Multiplying this by 5, you have 5 oxalate ion to produce 10 molecules of CO2 plus 10 electrons. You cancel 10 electrons at the left and 10 electrons at the right. The balance equation using half reaction method is 16 H positive plus 2 manganate ion plus 5 oxalate ion to produce 2 Mn plus 2 plus 8 molecules of water plus 10 molecules of carbon dioxide. Another simple redox reaction in acidic solution. Chromate ion plus chloride ion to produce Cr positive 3 plus chlorine gas. The reduction reaction is chromate ion to produce Cr positive 3. So first you have to balance metals, chromium. There are 2 chromium here, so you have to add 2 here. So this is balanced already. But if you notice, you need to balance oxygen, so you add water. How many? Oxygen 7, so you add coefficient 7 before water. Now in adding 7 to make 7 molecules of water, you also add 14 hydrogen atoms. So you balance this by adding H positive at the left. Now if you notice, the equation is already balanced, but then the charges are not balanced. To balance the charges left and right, you add 6 electrons at the left. 6 electrons, this is -6, plus 14 is 8, minus 2 is 6. So this is positive 6 at the left and positive 6 at the right, because 2 times 3 is 6. Now for the oxidation reaction, it is chloride to produce chlorine gas. Now to balance chloride and chlorine, you add 2 here in chloride, so there are 2 chloride and 1 chlorine gas. To balance the charges, you need to add 2 electrons, so this is -2 and -2. Now to balance the number of electrons at the left and right, or reduction or oxidation reaction, you have to multiply this by 3. So this becomes 6 chloride ion to produce 3 molecules of chlorine gas plus 6 electrons. Then you can cancel electrons. Now you add the half reaction for reduction and oxidation. So this is, you just copy it here and here. You cancel 6 electrons. So the balance equation is 14H positive plus Cr2O7 -2 plus 6 chloride to produce 2 Cr positive 3 plus 7 molecules of water plus 3 molecules of chlorine gas. Now let us balance another redox reaction in basic solution. And the equation is Cn negative plus MnO4 negative 1 to produce CnO negative 1 plus MnO2. Now, we have the half reaction method. Oxidation reaction is Cn negative to produce CnO negative. Now, to balance the number of oxygen, you add water. And to balance the number of hydrogen, you add H positive. And to balance the number of electron, you add electrons. Now, to neutralize, you add OH in both sides. 2 OH negative and 2 OH negative at the right. Now, OH plus H positive is equal to water. So, in adding 2 OH at the right, you produce 2 moles of water. Cancel out. So, this is 1, this is 2, you only have 1. So, this is the balanced oxidation reaction. Now, let us go to reduction reaction. MnO4 negative to produce MnO2. To balance oxygen, you add water. And to balance hydrogen, you add H positive. And to balance the charges, you add electrons. Now, this time, the same with oxidation reaction, you have to add OH to neutralize. And take note, OH ion plus H positive to produce water. In adding 4 OH negative at the left and right, you produce 4 molecules of water at the left. So, in producing this, you have 4 here and 2 here. Then you cancel out 4 minus 2. You only have 2 and no more molecules of water at the right. Now, this is now the balance equation, half reaction for reduction. Now, to balance, again, the number of electrons in the 2 half reaction, you multiply this by 3 at the left side and you multiply 2 at the right side to cancel the number of electrons. Then you add the 2 half reaction. So this is the half reaction for oxidation and the half reaction for reduction. The 2 half reaction and cancelling OH and water molecules in both sides, the balanced redox equation is 3Cn negative plus water plus 2MnO4 negative will produce 3CnO negative plus 2MnO2 plus 2OH negative. Redox reaction can also be balanced using the bridge method. In this method, it is simpler, but you need to have a mastery in solving oxidation number. In this reaction, magnesium plus HCl to produce magnesium chloride plus hydrogen gas. The oxidation number of magnesium here is 0, while here it is positive 2. Why positive 2? Because chloride is negative 1 times 2 is negative 2. So negative 2 plus positive 2 is 0. So this is positive 2. Now, from 0 to positive 2, this is 2 electron loss. Now for HCl, Cl is negative 1, so this is positive 1. So H here is positive 1, while in hydrogen gas, it is 0. So positive 1 to 0 is 1 electron gain. Take note again, electron is negatively charged. Now to balance this, multiply this by 2 to have balanced electron charge. So this is 2, so we put 2 here. So this is now balanced. Another example using the bridge method. Iron plus nickel nitrate to produce ferrous nitrate plus nickel. The oxidation number of iron here is 0, while the oxidation number of iron here is plus 2. Why plus 2? Because this is NO3 negative 1 times 2 is negative 2, so this is positive 2. Now nickel here the same. This is negative 1 times 2 is negative 2. This is positive 2. So positive 2 to 0. So in iron, 0 to positive 2, this is 2 electron loss. While in nickel, positive 2 to 0 is 2 electron gain. Actually, this is already balanced. To have a mastery of identifying, oxidizing, or reducing agents, balancing redox reaction using half reaction method or bridge method, I advise you to do these exercises. I'm ending my discussion here. I advise you to be proactive. If you have comments, feel free to contact me on the following medium of communications.